Okay, now we should be live. Yeah. Can you give us a feedback in the chat if you are able to hear us?
Yeah, I think that we are live,
Yeah.
but if there is anyone that can give us a feedback, could be perfect.
Yeah, because I can see the video. I can say that we had some technical problems. We are very, very sorry for this. Yes, if you can give us a feedback in the chat, if you are able to listen what we are saying. But from the live, from my phone, I can see the chat, so we should be live.
Yeah, maybe we can start, Luca. What do you think?
Yeah, I'm pretty sure. We can wait just a few more seconds because I have to set your screen, and we can start. So if you want to introduce yourself and us, for those of you that didn't attend the last seminar.
Yes, sure. So we are Matilde Anthony and Luca Garello, and we are the two MATLAB student ambassador of the University of Genoa. And today we will speak about MATLAB fundamentals. This seminar is the second part of MATLAB fundamentals. So we will continue with the topics of the last seminar. And what about me? I'm a neuroengineering student, and I hope that you will like this seminar. So, Luca, if you want to add something, you can do it, or maybe I can start if you have finished to set the screen.
Yes, we're ready. I think that we have lost enough time, so we can skip to your part.
Okay.
Thank you, Matilde.
So maybe I can share my screen.
Yeah, sure.
Okay, can you see it?
I can see it, yes.
Okay. So I think that we can start, and today we will speak about the first topic that we will face is indexing and logical operators. So first of all, which is the aim of this first section? We want to discover how to use the logical and the relational operators in order to study to verify if a condition is satisfied, and we also want to count the number of times that this condition is verified. After, we will want to extract data based on this result. So as you can see in the first figure, what we want to do is make a comparison between two different vectors, and we will obtain a result from this comparison. First of all, I think that we have to introduce what relational operators are. So as you can see in this table, there is a list of relational operators starting from sign of equal, greater than, less than, greater than or equal, less than or equal, and not equal. I think that maybe to understand what these relational operators are, maybe we can do some examples, and we can set the first variable, that is var, that is equal to 25, and we want to verify if the following condition is true. So first of all, our condition is var greater than 10. We know that the variable var is equal to 25. So we see that the number 25 is greater than 10. So the output of this condition will be 1. This is because when we have a condition that is satisfied, our logical value, so the output of our condition will be a 1. If our condition is not satisfied, so we have a condition that is false, our output will be a logical value equal to 0. In fact, we can see that 25 is greater than 10, so the first condition is true, but if we increase this value, we can see that when we arrive at the value of 25, this condition becomes false. So our logical value is converted to a 0. I think that we can pass to, we can go on and we can analyze the second condition. Our second condition is that var that is equal to 25 must be less than 5. But we know that 25 is greater than 5. So the result of this condition is a false value. The false value is represented by 0, as we can see by this logical value as output. We can go on and we can see the third and the last condition that we want to verify. Our variable var, we remember that this variable is equal to 25, and we want to satisfy this condition, so var equal to 25. Actually, we see that 25 is obviously equal to 25, so the result of this condition is 1 because the condition is satisfied. We have finished to speak about relational operators, and we can go on. We can speak about logical operators. I think that maybe you know these logical operators, but we can see the list of these logical operators in the table. So we see the AND logical operator, OR operator, and NOT operator. Also, in this case, we wanted to know if the following conditions are satisfied. So firstly we have to set a variable. In this case, our variable is a test, and we set a test equal to 5. The first condition is actually there are two different conditions. The condition test greater than pi, where pi is the mathematical constant already defined in MATLAB, and the second condition is the test less than 10. Why is the AND operator so important in MATLAB? Because in this case, this operator, so the logical operators, can gather two or more different conditions. In this case, we have the AND operator. So if we wanted to have as a result a logical value equal to 1, we have to satisfy not only the first condition, but also the second condition, test less than 10. So we see that our variable is equal to 5, so 5 is greater than pi, and at the same time 5 is less than 10. So both conditions are satisfied, and our output will be a logical value equal to 1. We can go on and we see the other two conditions that are gathered by a OR operator. In this case, the OR operator, if we want to have a logical value as output equal to 1, we have to satisfy only one of the two different conditions. So, or not only one, but almost one of these conditions. So we can satisfy only the first one, or only the second one, or we can satisfy both the conditions. To obtain the result equal to 1. In this case, we see that the test equal to 5 satisfies only the first condition, so we will obtain a result equal to 1. The last example is about this condition, test equal to 5. In this condition, test equal to 5, we know that this condition is satisfied because obviously 5 is equal to 5. So the result of this condition is 1. But this condition is preceded by the not operator. So this logical value equal to 1 will be converted in a logical value equal to 0, as we can see here in the output. So we saw how to use logical and relational operators. But why these logical and relational operators are so important in MATLAB, and why do we want to use it? We want to use them because they can help us to use logical indexing. What is logical indexing? We know that from the last seminar that if we want to extract data from a vector, we have to specify the number of rows and the number of columns corresponding to a specific element that we want to extract. In this case, we don't have a numeric indexing, but we want to access to extract data with logical indexing. So first of all, we have to create a logical array, and where a logical array is a set of different values, is a set of different logical values. So it is composed by 0 and 1, where 0 corresponds to false values, and 1 corresponds to the true values. Thanks to the logical indexing, we can use the logical arrays as index. In fact, we will obtain an array thanks to this index that we have obtained. So to make clear this concept, maybe we can do some examples in MATLAB. So first of all, we have to create a matrix. This matrix will be a 3x3 matrix, for example, and will be stored in the variable mat. After, we want to create a logical array. To create a logical array, we said that a logical array is a set of values of true values and false value. So before we saw that if we want to obtain a logical value, we have to make a comparison with the relational operators. So if we want to have multiple logical values, we have to make a comparison not between two values, but between a matrix or vectors with a specific value. So, for example, here we have a comparison between the matrix mat and the value 7. Each element of the matrix mat is compared with the value 7. The output of this comparison will be a logical array composed by 0, where the the condition is satisfied, is not satisfied, and 1 when the condition is satisfied. So, for example, we see that in the matrix MET we have the first value that is equal to 5. 5 is not greater than 7, but is less than 7. So this condition, MET greater than 7, is not satisfied. And we will have in the first position a logical value equal to 0. But if we consider this value is equal to 10, so it's greater than 7, and so this condition is satisfied, and we will obtain a 1 as output in the corresponding position. So we can go on, and we want to explain why logical arrays are useful. Once we have created the logical array, we can use it as index. So we don't use a numeric index specifying the number of rows and the number of columns of that position of the element, but we want to use as index the logical array. In this case, we have the logical array from obtained by the condition MET greater than 5, and thanks to this logical array will be extracted from MET all the elements that are true. So all the elements that have a value that has a corresponding value equal to 1 in the logical array. So, for example, we see that the first element of this vector will be 7, because the first element not equal to the first element greater than 5 here in the matrix MET is 7. This means that in our logical array MET greater than 5, we will have in the corresponding position of 7 a logical value equal to 1. In this case, we will obtain as index the logical array, and we will extract only the element that have a corresponding value that is 1. We can also do comparison between two matrices. So, for example, we create two different matrices B and C, and we want to compare them. To make this comparison, we can use another time the relational operator greater than. What we are comparing is the two elements, the two corresponding elements in B and C. So, for example, in the first position there is a logical value equal to 0, because we see that 1 is not greater than 50. But in the last position we have a logical value equal to 1, because 5 is greater than 3, so the condition is satisfied. Now we can go on, and we can see that a relational logical operator can help us also to replace some elements in our matrix, in our vector, with a specific value. So, for example, here we have that the element of C that are greater than 10 or equal to 3 have to be replaced by a 0. In fact, we see that the matrix C has in the first position 50. 50 is greater than 10, and this value will be replaced by a 0. And in the last position, this matrix has 3. So we will have in the last position a 0, because we have replaced this value. Now we can go on and we can see that there are different functions that allow us to count elements. So for example, we can start from the function find. Find is important because it allows us to find the indices corresponding to the true value in an array. So, for example, we have our logical array mat greater than 7, and we know that the logical array will be composed by a true element equal to 1 and a false element equal to 0. Now we have that this logical array will be the input of the function find. Thanks to this function, we will store the indices corresponding of the true elements in the variable edx. So we store the position of the true elements in this variable, and after we can use it, and we can use as indices to extract the new data. So if we remember the matrix mat, and the metric, the logical array mat greater than 7, we can see that mat is this matrix, and the logical array is mat greater than 7 here, and so only the corresponding values in the position of 1 will be extracted. So only 10, only 14, and only 20. To be precise, we have to start from 14, 10, and 20. In fact, we will see that our output is 14, 10, and 20. So we can go on, we can see another function that is really useful, and this function is any. We can define two different vectors, and we want to compare them. If we compare them with the sign of less than, we will obtain a logical array. The function any permits to understand if there are any elements, any of the elements of the logical array are true. In this case, there are 4 different elements that are true. So the output of this function is a logical value equal to 1. If we want to see instead if we have all elements in this logical array that are true, so all elements have to be equal to 1, we have to use the function whole. The input of the function whole is our logical array. And we see that in this case, in our case, our logical vector has a false element in the first position. So we know that not all elements are true. And for this reason, our logical value will be a 0. But we can use another function to count the non-zero values in our logical array. In fact, with this function hanzed, we can count the number of ones in this logical array. In this case, we have 4 elements equal to 1, so we will count 4 elements. Now we can go on and we can see the importance of tables of data. So the aim of this section is consists in working with data that are stored as tables. Why do we have to use tables instead of metrics? For example, here in the figure we can we can give an explanation about why we use tables instead of metrics, because we know that in metrics can be produced a mismatch because if we have each column of the matrix with different data types, so we have a string, for example, in the first column and a numeric array in the second column, we will produce a mismatch in the matrix. But if we do the same operation for the table, we will obtain a correct operation. So we will table can help us to handle different data types at the same time. When we have tables, first of all, we have to import data, because sometimes we have data, we want to import data from existing file, and we want to import them in MATLAB. To import the data in MATLAB, we can do two different operations. The first one is to import data from tab home, and we can click on import data, and we will select the file that we want to import. But if we want, for example, import data from MATLAB with a line of code, we have to use the readTable function. First of all, we have the readTable function, and we want to specify the name of the file. In this case, this file is a text file. If you write this line of code, we will store the new table that we want to import in MATLAB in the variable citytemp. In fact, as we can see in this output, we have the output citytemp with this table that has been imported. If we want to see the statistics of the table, we can use the function summary, and as input we can write the name of the variable in which the table is stored. The statistics of the table are the minimum value of the table, 2, as we can see in the table, the median value, that is 8, and the maximum value, the median value, that is 5, and the maximum value, that is 8. Now we can also visualize data. So we can use a plotting function of the last seminar, so in this case histogram, and we want to extract the first column of the table if we want to specify the categories, and the bin counts will correspond to the second column of the table. To do that, we have to use the dot notation. The notation allows us to specify the table that we want to consider as the first term, and after the dot we have to specify the variable that we want to consider. So the categories will be the cities, and the bin counts will be the temperature. So using the dot notation, we will extract only, in the first case, only the values, only the strings corresponding to the city, and in the second case, only the values corresponding to the temperature. And we can see, like in the last seminar, that we specify the color inside the bar, that is equal to yellow, and the color, the edge of the bars, that is green, as we can see in this line of the code. So we saw how to import data from an existing file, but maybe we want to create a table from workspace variables, so from variables that are in our workspace. So we create two different arrays. The first one is a cell array, because if we want to gather different strings, we have to use the cell array. So the cell array is defined by not the square brackets, but in this case by the curly brackets. While in the second case, we want to define another vector that in this case is a numeric vector. It is a numeric vector. In fact, it is specified by the square brackets. In order to create a table from these two variables, we have to use the function table. The function table requires as a first input the first column, so in this case team, and the second column as for a second input there will be wins, so the second vector that we have defined. After, we can also define the variable names and that will be teams and wins. Also in this case, we have to specify the curly brackets, because we are specifying two multiple variable names. These variable names will be displayed at the top of the table. So as we can see in here in the output, we have team and wins, because our variable names are team and wins. Why we use the single quotes here for team and also for wins? Because we have defined two row vectors. In this case, a row cell array, and in this case, in the second case, a row numeric array. So if we want to obtain this result, two columns that have the same length, we have to transpose the row vector in order to convert it in a column vector. We can also create a table if we have a previous array. So, for example, if we define a vector which contains the student's age, so from 12 to 19, and a vector hence student that contains the number of students with the same age. If we concatenate these two vectors and before we transpose the two vectors in order to obtain two column vectors that are concatenated, we obtain the array R. Now, with the function array to table, we can convert the first input, so the array R, into a table. And also in this case, we can specify the variable names between curly brackets. And remember that these two variable names will be displayed at the top of the table. Another important function when we are using table, another important function is the function sort. The function sort rows, and we can see that. Thanks to the function sort rows, we can sort our table. In this case, our table is tab R, and if we want to sort a row according to the variable number of students, so we consider only the elements of the number of students, and we want to order them in an ascending way, we will write this line of code. If we wanted to sort the rows of the table according to not only one variable but multiple variables, we have to select the table that we wanted to sort, and we have to select also the variables that we want to consider. In this case, we will consider in the first time we will consider the elements of the variable age, and we will order and sort them in a descending way. After, we will sort the table also considering the elements of the n students. So before, in the first time, we consider the variable age, and in the second time, we consider the variable n students. In this case, we have also specified the order that we wanted to follow. So in this case, a descending order and not in an ascending order like the first one. In fact, if you don't specify anything, the default order is the ascending one. We can go on and we can talk about indexing. If you remember, in an array, we saw that if you want to extract data from an array, you have two different possibilities. You can extract data with numeric indexing, so specifying the number of the column and the number of the row. But you can also use the logical indexing. In this case, in table, we have different types of indexing. The first type of indexing is the numeric one, and we can see that is equal to the indexing for array. So we have round brackets in the first position. We have to specify the number of rows that we want to consider. So in this case, from the first row to the row that corresponds to the half length of the vector age. But in the second position, we have to specify the column that we want to consider. In this case, we have the signed column, so we have to consider all the columns that are in the tables. In fact, we will obtain from our table tab bar, that is this one, we will obtain only a half table. In fact, we have only 4 rows. We can go on and we can see another type of indexing. So if we want to use to select a column in another way, we can use the variables in single quotes. For example, we can extract a table that contains only the first column of page. So we want all the rows in the first position thanks to the sign of column, and we want to specify not the number of row, but in this case we specify the name of the variable that corresponds to one of the columns that are present in the table. In this case, we extract the column age. We can also see a combination between these types of indexing, and we can use to extract data. We can use a numeric array to extract data from the first, the third, and fourth row. But we can use with the curly brackets the variable that we wanted to consider. So in this case, age and number of students. Now that we saw the different types of indexing, we can see different functions that can be useful in tables. The first function that we, first of all, if we want to remove variables from a table, we can use two different ways. So in the first way, we can use the square brackets, and so we select with the numeric indexing, we select the row on the column that we want to remove, and we write this line of code, so with the square brackets that has nothing inside. In this case, we see that we will take the table half a tab bar. In this table, we want to select the third row and hold the columns, so we consider all the third row, and we want to remove them. To remove them, we will write the two square brackets. But if we want to remove a variable in the table, so we can use the function remove vars, and as a first input we can write the table, and as second input we can specify the variable that we want to remove. In this case, we knew that we had two different variables, the variables age and the variable number of students, and in this case we want to remove the column age. So the output will be composed only by the column number of students. But in tables, we can also move variables. So, for example, if we have in our table is this one, and we have a column with age and a column of number of students, and we want to move the column of age after the number of students. To do that, we want to write this command. So we use the function move vars, and as first input, it requires the name of the table. After, we have to specify the variable of the name of the variable that we want to move. The name of the variable will be followed by the after or before. So if we want to move this variable after another variable, we have to write after. And the reference variable will be the last input. So with this line of code, we will obtain this result, and we notice that the column age now is actually is after the number of students. If we repeat this command and we use and we write before. In this case, we will come back to the previous table. So we will obtain a table with the first column that corresponds to the age, to the student's age, and the second column that corresponds to the number of students. In fact, if we display the original table, we see that the two tables are the same. So we saw that if we want to extract data from a table and we want to obtain the same data type, we can use the dot notation. In the first term of the dot notation, we have to select the name of the table, and as a second term after the dot, we have to specify the column so the variable that we wanted to consider. In this case, we will extract only the column corresponding to the age in the table alpha tab r, and this operation can be done also for the number of students. We can, if we have created a table, in a second moment we can also create new variables in our table. So, for example, we can we want to add this last column, new number of students, and it is possible thanks to the curly brackets. So we have to define our the table that we want to modify, and we want to also define inside the curly brackets the new variable that we want to create. So in this case, the new number of students. This statement will be followed by the definition of the elements of this new variable. So we will have elements from 2 to 16 with the step of 2. But if we wanted to create a new variable, we can see that we can use also the dot notation. For example, here we want to create in the tab r that is our table, and we want to create a new variable total number of students. To create it, we use this dot notation, and thanks to the dot notation, we can do the operation that you can see here. So you can extract the number of students and then the new number of students, and you can sum them in order to obtain the total number of students. So 20 will be summed to 2, and we will obtain 22. We can use also the curly brackets not only to add a column in the table, but we can also use these curly brackets to change multiple variables. So, for example, in this case, we change the element that has a position that corresponds to the first row and corresponds to the variable number of students, a new number of students. So we consider the first row, that is this one, and only for the variable number of students and then the variable new number of students. And we can see that the first element will be replaced by 10, as we can see here, and the second term will be replaced by 30, as we can see here. When we have created tables, we can also save them, and we can also create new file with different file extensions. So we will have text file, we will have a CSV file and XLSX file. In this case, we want to create, thanks to the function write table, we wanted to specify as first input the table that we wanted to export, and we wanted to also to specify the name of the file that we want to create. If you want to specify the limiter of the limiter that will characterize this file, you can specify the limiter after the delimiter that you want to specify. Now we can see concatenation. So we saw in the last seminar that we can concatenate two different arrays, but we can also concatenate different tables. For example, if you have different tables, in this case, we have only the table for the number of students and only the table for age, the students of the age, and we want to gather it in order to obtain this result. We can use the square brackets. In fact, we select the first table that corresponds to the first column and the second table that corresponds to the second column. Thanks to the square brackets, we can join them. But if we have two tables and these two tables share a common variable, that is age in this case, we can't use the square bracket to join them, but we have to use a specific function, that is join. Thanks to this specific function, we will obtain this result. So the first column corresponds to the shared variable, and the second column and the third column correspond to the other variables that we wanted to join. To conclude this part of the seminar, we want to analyze and we want to represent different points, specific points in time. So first of all, if we want to specify a point in time, we have to create a variable, a datetime variable. So first of all, we want to create a date in time. To do this, we have to select the number of the day, in this case 9, the number of month, in this case the first month that corresponds to January, and here that corresponds to 1890. Thanks to the function datetime, we will have as first input the year, as second input the month, and as third input the day. Thanks to the function datetime, we will create our date that corresponds to the 9th of January in 1890. But we want also to calculate a period of time, so we can set a second date that corresponds to a date with the same day, the same month, but with a year that corresponds to 1891. In this case, the difference between day 1 and day 2 will correspond to 1 year. In fact, if we want to see this difference, this period of time between day 2 and day 1, and we want to see this result in days, thanks to the function days, we will see that the difference between these two dates corresponds to 365 days. If we wanted to see the last example, we see that we want to represent the Sally's age on the 8th of August every year from a period of time from 1991 to 2011. We wanted to create a table, so we use the function table. And as a first input, we will have the elements of the first column. So the element of the first column will correspond with the same day, the same month, and a period of time from 1991 and 2011. After a second input, we want to specify the age of Sally's age, so from 23 to 33, and after we will see the variable names that will be displayed at the top of the table. finally, we can see that if we want to sort the data from the recent from this recent element, the most recent element to the most ancient element, we have to use the command sort rows. As first input, we will have the table date table, and as second input, we have the variable that we want to consider to sort the table. And as third input, we can specify the order that we want to follow. So in this case, descending way. So from the most recent element to the from the most recent element to the ancient to the most ancient element. So if you have any question, you can tell me. Because I have finished the presentation. So Luca, if you know if there are any questions, or if you want to start with your presentation, we can go on.
Okay, Matilde, thank you for your presentation. We don't have questions up to now, so we can switch. And
Okay.
if you want, we can start with the second part.
You can share your screen.
Yeah, sure. Give me a second. So okay, now you should be able to see my screen. Today, for my part, I will talk about data analysis, and in particular, the case of missing data. As you can see from this graph, it can happen that your data have missing data, of course. And how can we deal with this? So we have basically three options. The first one is to ignore the missing data, the missing values. The second option is to delete these values, and I would say that the first and the second option are very similar. We can ignore or delete the data, and the result will be the same. The third option that is very interesting, but of course it depends on your data, is to replace the missing values. Now you may wonder which one is the best way of dealing with missing data. Well, there is not a best practice because it depends on your data, and we will see when is the case of ignoring or deleting your data, or when it is useful to replace the missing values. So we can start with ignoring nonce. So the case when we want to ignore the missing values. Here I have declared an array that should represent the temperature that we get from a sensor. So I can plot this data that is the data we are working on. Then here we can see how in some parts of our daily temperature we can see how these data affect the plot. So the first thing that we can do is, of course, to calculate the mean, or to calculate some statistics. And if we use the simple function mean on our array of temperatures, we will end up with a none non-value. So if we try to evaluate the mean of a matrix or an array with non-values, we get this non-value. The problem is that none, of course, is not the mean, and if we want to extract the mean, we have to specify we have to modify the flag omit none, and in this way we can evaluate the mean ignoring all the non-values. Now I can run the section, and here we have our mean temperature. The message from this part of the script is that when you want to use a statistic function, you have to keep in mind that you also have to use omit none in order to ignore all the non-values. The second option, as we have said, is to delete the non-values. But before deleting these values, we must know where they are. And we can do this, we can find them using the isMissing function that will find the non-values for us. As we have seen with Matilde, it is possible to localize values using indexes. So let's try this function, and as you can see, the isMissing function is giving us the values of the positions where we have non-values. I can print again the temperature, and as you can see, in the third position we have the none, and so on. So with isMissing we can localize our non-values, and we can also count the number of missing values. This is possible using the sum. So we are going to sum all the indexes, so all the missing values. If we run the sum on this array idx, we get 3. That is the number of missing values. There is another possibility, that is this function nnz, that will perform something very similar to the sum, but it will give us the number of non-zero numbers. So the sum works in this case only if we have zeros and ones, but with nnz we can also have zeros and other values different from 0. Just to check with you, we have the same output. Okay, so now we can extract all the none values that are in our temperature array. So we can invert our indices using the not function. So what we are going to do is we are going to use this new index array that describe all the non values, and if we access the matrix X with these indexes, we are going to extract the matrix Z that is composed of non values, and this is how we can extract the non values. Another possibility is to use this tilde as in substitution of not. It does exactly the same. It will invert. It will convert 0 to ones and ones to 0. It's exactly the same thing, but since I'm using an Italian keyboard, I don't have this symbol on my keyboard, so I have to use a shortcut, and I usually don't remember these shortcuts. So for me, it's way easier to use not, but keep in mind that this is the same. Another thing that we can do, of course, it is different operations on our non-none values, so on our data. For example, we can use the prod function that will evaluate the product of all elements in X. As we've seen, we can ignore the non-elements using our matrix Z that is composed of the values that we have extracted before. Okay, I think that this is somehow useless, but just to say that once you have extracted all your elements, you can perform all the operations that you want. And finally, here in task 5, we can remove the non-values. So here in matrix Z, we have extracted the values, but if we want to keep using the matrix X, we can just delete the non-values from the original matrix X. So this is possible just by assigning an empty cell to the non-values. So here I run the section, and as you can see, if we assign an empty cell to the position of the non-values, we will get the same array that we have extracted before just by accessing all the non values. Okay, so you may wonder what happens when we work with matrices. So it is exactly the same thing. Here I can declare a random matrix with a dimension 50 by 4. It is possible to extract the number of rows that contain missing nonce with any and is missing in this way. Okay, and here we have our indexes, the indexes of non values. In the same way as before, we can assign this empty value, let's say, to the non-values, and in this way we are going to remove all the rows of the matrix Z that contain non-values. Okay, and this is our new matrix without non-values. Another interesting thing is to replace non-values. I think that this is probably the most interesting part of this script. In fact, for some reason, you may want to fill these gaps. How can we do it? Of course, you can do it manually. So if you have enough fantasy, you can decide the value that is missing. Another possibility is to use the MATLAB functions, or functions that are defined by you, but in any case functions, and we are going to see which are the possibilities. The most important function for doing this is fill missing. So with fill missing, we can decide, of course, the matrix we are going to use, and the method of interpolation here I run the script. Okay, I have assigned the new um, uh, array of temperatures to y, and then I can plot y. Okay, and here you see how MATLAB is able to interpolate the missing data. For doing this, we have used the linear interpolation. I think that this is a plausible interpolation, because usually temperature uh, doesn't oscillate a lot, so this is reasonable. But if you want to use different methods, of course you can decide other methods. For example, Makima is another method for doing this. I run again fill missing, and then I plot, and here you should see that different methods lead to different interpolations. Again, which is the best method? It depends on your data. Here I wanted to show you that you can get different results. So it depends from your data. When you want to check a function, as we have seen in the last seminar, you can type doc, that stands for documentation, and then fill missing, okay. I wanted to show you that it is possible to implement fill missing with different methods, and if we open the documentation, you can see that of course there are many arguments for this function, but we are interested in the method. So here I click on method, and these are all the different methods that you can use for interpolating your data. And again, which one is the best? It depends on your data. Okay, just to conclude this part, you may wonder which one of these is the best way. I told it at the beginning of this script. Depends on your data, and I want to make an example of case in which it is good to delete or ignore the data. For example, if you have a temperature sensor that acquire the temperature 3 times per hour, and you have a missing value, you can assume that in an hour the temperature is not going to change a lot. So if you have a sort of redundancy, or in general high frequency of your sampling, you can decide to ignore data. But if you acquire the temperature daily, so you have one measurement per day, probably it is good to use a linear interpolation, and this is what we can do with missing data. The second script that I prepared today is on decision branching. In particular, we are going to talk about the if statement, if-else statement, about for loops, about while loops. Okay, so I wanted to show you an example that probably is useful to understand the use of if and else statements. So we want to start the air conditioning only if the temperature is greater than 30 degrees Celsius. Here with the randy function, we are going to generate a random temperature in the interval between 0 and 40. Then we are going to evaluate the temperature. If the temperature is higher than 30, we are going to switch on the air conditioning. Otherwise, so else, we are going to switch off our air conditioning. How can we implement this reasoning with the code? Of course, in this way. So I run the section. Okay, as you can see, the temperature now is 39. So this condition is satisfied. So we will execute this part of the code. So I is equal true. So here we can see that I is equal 1. 1 is for true and 0 is for false. Okay, let's try it again. Okay, now the temperature is 23. This statement is not satisfied, so this part of the code will not be executed, and so it will be executed the else statement. Okay, and this is a very simple example of if and else, but you can also use else if, and this is a graphical representation of your reasoning. So if the first if is not satisfied, you are going to evaluate the second statement, the second if, sorry, and if the second if is not satisfied, then you are going to evaluate the third, and so on. Here the exercise is a bit different. We have to decide our outfit according to the temperature. We are going to use if and else. So again, we are going to generate a random temperature, and let's see. The temperature is 37 degrees. If temperature is under 15, this is not satisfied, so we go to the next if. Here we evaluated again the temperature. The temperature is not under 20, so we will not execute this part of the code. We go to the other if. This time again the temperature is higher than 30, so we are not going to execute this part, so we fall in the else statement. Whatever is written here, if we reach the else, we are going to execute this part of the code, and this is what we see in the output. Stay at home, it's too hot. Another run. Let's see 26. With 26 we are going to execute this part of the code, because this is not true. You can again look at this picture. This is not true. This is not true, and so we run this part of the code because this is true. I hope it is clear. It's easier to read it than to explain it, but this is how we can implement the if and else if. Then the last, no, it's not last. So for loops. Usually for loops are used for accessing the values in an array or in a matrix. For example, we can declare an array. Let's see it. Okay, we can declare an array X with these random values. They are not important. And maybe we may want to print the first 4 elements. With for loops, we can iterate through this vector. What is the syntax of for loops? We have, of course, the for. Then we have a variable that changes for each iteration, in each iteration, and this value is going to change from 1 to 4, so it will assume the values of 1, 2, 3, and 4. And this is exactly what we do in this for loop. So with the first iteration, the IDX is 1, and we're going to print the first value, okay, and this is 8. Then again, IDX is 2, and so we print the second one, and so on and so forth. Here we decide the range of our for loop, but we can also use different ranges of values. So, for example, we can modify the range to start at 1 and at 5, but incrementing IDX by 2, and this is what we can do here. So again, the values will be 1, 3, and 5. So the first, third, and fifth. If we want to iterate over an array, of course we can extend the range of our variable. So we can extract the length of our array. This array X was 1 by 10, so we can extract the length using the function length. We can assign the length to the variable L, and here we can iterate over the entire array. So this time IDX will start at 1 and will end at 10. And here we have the result: 1, 2, IDX equal 1, equal 2, equal 3, and so on, until the end of the array. Okay, last branching that I want to show you is the while loop. We use while loops when we don't know how many iterations we are going to run. Of course, because here we knew how many times we are going to evaluate our array, but with while loops we don't have this knowledge, of course. And here you can see the different examples. Of course, if you access arrays and you know the dimensions or similar things, you will use for loops, but otherwise you are going to use while loops. Here I prepared a very stupid and simple example of a die that we are going to roll a die, and we win only if the number of the die is 6. Before rolling the die, we have to declare the variable die that will store the value of our die. At the first run, the value of the die will be none, and then we'll roll the die. Okay, I run first iteration. The die is 1, so we still stay inside our while loop, and we are going to exit only when the die will be equal to 6. Okay, I run it twice, but it's the same. So with 5, we stay inside and we iterate another time, and so on until we get the 6. And with 6, this condition is no more true. This condition in particular is die different from 6, and when the die is equal to 6, so this condition is no more true, we exit from the while function. Okay, the last thing that I want to show you is how to create and call functions. I think I can clear the output here. Clear the output. This is the syntax. When we want to call a function from our code, we are going to follow this syntax. Of course, our custom function must be written somewhere. Where can we write our function? Of course, in another file. Here I can start from scratch. Okay, I can write another function. How can we write a function? We go to on this button, we press and we select the function, and we get this skeleton, so this template, let's say. And here we can decide the name of our function, that with a lot of fantasy will be called my function. Here we have the 2 arguments, but of course you can add as many arguments as you want. We can stay with 2 arguments, and here we have the output of our function, that again can be 1, 0, or the number that you prefer. Here we can use just one output, so we can use output. Okay, we are going to design a function that takes as input 2 matrices and evaluate the sum of these 2 matrices. Okay, so the output is going to be, the output here, you have to use the same variable, because this is the variable that will be that you will get from your code. So output, it will be the input. Okay, you can copy and paste. It will be the first argument plus the second argument. Easy, very easy. Okay, we have defined our function, but we still have to save it. So we can save it. MATLAB fundamental. Okay, I can save it here. Okay, this is our function, and from the code here we can call the function that we have created. So my function here, MATLAB is saying that we can call the function my function. There is this help, my function, then we have to specify, of course, the two arguments that we have specified here. The name of the arguments here, it's the one you prefer. So it can be matrix A, matrix A, and matrix B, and the output is going to be the matrix AB. Okay, so I can delete this. Matrix A now is equal to round 4 by 4. Okay, we can use we can create a square matrix. Then B is the other argument of our function. This can be again around. Let's use Randy. Randy 10. The first argument is the maximum value of this matrix, and the other two parameters are the sizes of our matrix. So if we want to compute the sum of two matrices, we know that they must be of the same dimension. So if matrix A is 4 by 4, also B must be 4 by 4. Okay, and this is the declaration of B. Let's see, I can comment this line of the code and see if we are creating two matrices as we wanted, and here we can see that we did the right things. Okay, so now we can compute the sum of A and B. Okay, and here we have we get the sum of the two matrices, matrix A and matrix B. What we are seeing is not only the output of the function, but also the code inside the function, because here I forgot to use the semicolon. If I don't use the semicolon, here I'm going to see the output, all the outputs that are generated inside. So if I type display, no, sorry, it was disp, I think, disp inside function. I think that this is somehow trivial for many of you, but I'm going to see the outputs from inside the function. Okay, here I can decide to hide the output variable using the semicolon. I'm still able to access to the output from my code using AB, and here I get AB, and I'm no more able to see output. Okay, and this is a very very simple, stupid example of how to create functions. The very last thing that I want to show you, I think that we have finished, is that you have to create your function in the same folder of your code. So if we want to call my function, from our code and the function must be in the same folder. What if we want to put my function somewhere else? when, well, we can move my function to functions, to another folder in general, uh, whatever we want, and then we can add to our code the folder that contains our function. So we can use add path, and here we can specify the name of our folders. It should be worked. Now I'm okay, and we are still able to call my function. If I don't add the specific folder with my function, I will not be able to use the file I've created. Last thing is this one. Sorry, we can. No, I don't remember from where was it. Okay, I wasn't able to see the icon because it was minimized. It was here. In environment, you can also add a folder from here, from set path, and as you can see now, we added this folder, the folder that contains our function from the code, but we can also do it manually from the graphic interface using a set path. Okay, I think that we are done. Matilde, are you still there? I don't know.
Yes.
Okay.
Here I am.
Perfect. So we can conclude this seminar.
Yeah, I think so. Maybe we can promote our social network group. What do you think, Luca?
Yes, of course we have.
Remember to join join our group on Facebook and on Instagram, and there are the links on in the description of the video. Is it right, Luca?
Yes, you can find all the links in the description. For us, it's very important to keep interacting with you, also on our social media. So if you enjoy this seminar, you are invited to join on our social.
Yes, so that they can know when our next seminar will be, so they can follow us.
Of course.
If they want.
Yeah, sure.
So maybe we can conclude here. What do you think, Luca?
Yes, I think that we said a lot of things, and thank you all.
Thank you. See you on the next seminar.
See
Bye-bye.
you on our social. Bye-bye.